This lecture is on biogeochemical cycles. So during this lecture, we will talk about an introduction to these cycles, the water cycle, carbon, and then nitrogen. Now you have your learning objectives written on a page in Canvas, but they are also in the PowerPoint. So the learning objectives for the introduction are to define an element and a compound. We're also you need to be able to identify which geologic processes contribute to the recycling of chemicals, and finally, explain the concept or definition of biogeochemical cycles. Now, first of all, I gave you a link to Khan Academy biogeochemical cycles in your module. So I highly recommend that you read all the information in this Khan Academy lesson and also view the videos. Now, the information that I put in the PowerPoint mostly comes from the Khan Academy lesson. So if you need any reinforcement or you want to go back and look at some of these concepts, that's the resource you should use. So let's talk about an element. So an element is actually an atom which has certain characteristics, like for instance, carbon is an element, nitrogen, oxygen, and these all have specific atomic characteristics, which you don't need to worry about for this class, but I do want you to know that an element refers to a certain type of atom. And that's where, like the periodic table, which you probably saw when you took chemistry, the periodic table shows you all of the different elements. Now, a compound is two or more atoms bonded together. So for instance, water, H2O, is a compound. It has two hydrogen atoms and an oxygen atom. And carbon dioxide, another very important compound, has a carbon and two oxygens. Now, the first thing that you need to know about these cycles is that sunlight is the ultimate source of energy for the Earth, for our ecosystems, and for all of these cycles. Now, sunlight, as we talked about in the lecture on food webs, is taken in as a source of energy by producers. And these producers, or autotrophs, use the sunlight to make sugar. And that is an energy source for all other organisms in the ecosystem, well, most other organisms. Now, for sunlight and energy, it enters the system, meaning like an ecosystem on Earth, right? But most of it leaves in the form of heat. Remember that we talked about every time energy goes from one organism or one trophic level to the next, only 10% of that energy remains. The rest of it is lost as heat. So the bottom line is that we need a constant supply of energy. And like I told you before, if we had no sun, life on Earth would die because we need that constant input of energy. Now, chemicals in the ecosystem are recycled. And by chemicals, I mean carbon, or like water or nitrogen. Right? These are recycled. They go through and through our ecosystems, and they move between organisms, living organisms, but also like the soil, right? So living and non-living parts of the ecosystem. Now we have a name for living organisms, and that is biotic. Now the name for non-living characteristics like temperature or precipitation, humidity, those are called abiotic, meaning that they are not living. So the first thing that you need to know on this slide is the 6 most common elements that you find in, I put organic molecules, but also just in living organisms. Organic molecules mean molecules with carbon. Now, if you look over to the right here, I put CHNOPS. Those are the symbols for the 6 most common elements. I'm going to write that down for you. But like I said, all of this information is in the Khan Academy reading. I'm going to try to move my taskbar here. There we go. I have another screen on the side, which is why I look over there sometimes. Okay, so the 6 most common elements are carbon, which is symbolized with a C, as you could probably guess. Hydrogen with an H. I just don't have to capitalize that. Nitrogen with an N. Oxygen. Now, look at the P and the S and think about what those mean. I know you've heard of them. So you have phosphorus and sulfur. So these elements are the most common elements in your body. Now, the reason that I had you look at these elements is that they are involved in the cycles that we see in the ecosystems. Now, we are only going to talk about water, carbon, and nitrogen. However, the phosphorus cycle and sulfur are all very important as well. Now, keep in mind that water is not an element, right? It's a molecule, 2 hydrogens and an oxygen. Whereas the carbon cycle and the nitrogen cycle, we are talking about like elements. So these chemicals can be stored in the atmosphere, right? The air around us. They can also be stored in water and under the Earth's surface. One moment here. Now, the question that I asked you on this slide is what type of geologic processes contribute to the recycling of chemicals? Now, remember that a geologic process is something that has to do with, say, the abiotic part of the ecosystem. So for this, we're talking about like the weathering of rocks, right? The breakdown of rocks. Erosion, which is when water runs over a surface and starts to like wash part of it away. We see that in like riverbanks, things like that. Also on the soil where we use a lot of crops and irrigation. Other geologic processes would be like volcanoes or movement of the tectonic plates, right? So all of these geologic processes also come into play when we're talking about biogeochemical cycles. One second here. Okay, sorry about that. I was having an issue with my PowerPoint. Okay, so in this picture, all I really want you to see here is the different parts of the Earth and where these chemical cycles occur. So we have the atmosphere, right? So there's different layers of the atmosphere, but we are mostly concerned with the layer of the atmosphere that is closest to the Earth's surface. we have what we call the hydrosphere. Now think hydro, water, hydrate. The hydrosphere is all the surfaces on Earth that contain water, like your oceans, your rivers, lakes, things like that. It can also include water under the Earth's surface, right? Groundwater, and also water vapor in the atmosphere. So water vapor refers to a gas, right? And in this picture, there is also the lithosphere, which you can see it's kind of that cream colored layer down there, and that's like the Earth's crust. Now on here, I put the question, what is the definition of a biogeochemical cycle? So I took the definition from the Khan Academy reading that I gave you. So the cycle is referring to the ways in which an element or a molecule such as water moves between living and non-living forms and locations on the Earth. So let me repeat that for you. Actually, I'm going to write that down. So I'll write the definition under here. Okay, this is not exactly the same as the Khan Academy, but it means the same thing. So the ways in which an element like carbon or nitrogen or a molecule like water moves between living and non-living forms, meaning like organisms versus say the soil, right? And also how it moves between different locations on Earth. For instance, does it go from the atmosphere to the hydrosphere? And so it's biogeochemical cycles look at this movement around the ecosystem, around different locations on Earth. Okay, so let's go into the water cycle. So your learning objectives are to define the following terms: groundwater, evaporation, precipitation, and transpiration. And these all have to do with different movements of water throughout the cycle. I want you to explain which two processes can occur in a terrestrial ecosystem once water reaches the surface. Now, terrestrial means like on the ground. And then I also want you to be able to discuss the relationship between the terms that I had you define. So the relationship between the processes of evaporation, precipitation, transpiration, and the formation of groundwater. Okay, so let's go over some basic information. I already told you water has 2 hydrogen atoms and oxygen. Now, water is absolutely essential to life, which you probably know. Most of your body is made of water, or a lot of your body is made of water, right? And then also water can be present in 3 different states. What that means is water can be liquid, ice, or water vapor, which is a gas. Now, my question here is, what is the hydrosphere? And we talked about that earlier. Also, it's in your reading. So I'm going to let you go back and review that on your own. So, more basic facts about water. Most of the water on the Earth's surface is salt water. Very little of it is actually fresh water. And of the percentage of water that is fresh water, most of it is trapped as ice and glaciers, things like that. So fresh water in lakes, water that we can access and drink is only a very small percentage of the water found on Earth. Now, the water found in ice and glaciers and under the Earth's surface cycles very slowly through the ecosystem, whereas water that's on the surface, like rivers and lakes, that cycles very rapidly, meaning that it goes from location to location very quickly. The water cycle has many state changes, right? From ice to liquid or liquid to gas. And then finally, and here's a definition that you need to know, groundwater is water that is found between soil particles and like crevices of rocks, right? Groundwater is under the surface of the earth. And generally, when we get rain, it goes down through those soil particles, finally reaches an area called the water table, and that's kind of where it sits. Now, here is the water cycle picture from Khan Academy. You do not have to know all of the details of these pictures. So use it just to reinforce the information on the slide or to answer the questions that I've given you. So I mentioned before that the sun is the ultimate source of energy. Well, it is energy from the sun that keeps the water cycle moving. Okay, now the first thing that energy from the sun does is it leads to evaporation. And that is another term that you need to know. And evaporation occurs when liquid water turns into a gas, right? Turns into water vapor. And we actually have a lot of water vapor in our atmosphere. Now, the question that I gave you here is, what is precipitation and how does it occur? So let's look at the picture here. You can see these little red lines coming up from the ocean. I believe that's the ocean there. And that signals evaporation, right? Liquid water is turning into water vapor in the atmosphere from the body of water there, like the ocean. Now here we see the word condensation. Basically, think of condense, right? So you take something and you condense it, you put it into a tighter space. So basically, you're taking water vapor, which is spread out in the atmosphere, and it's condensing into a cloud, right? So after that, you get precipitation, which is rain or snow, water falling back to the surface of the earth. Again, I used the same picture for all of my water cycle slides. So once water reaches the Earth's surface as rain or snow, it can evaporate again. So you have liquid water, it evaporates, it turns into water vapor in the atmosphere, it condenses into a cloud, and then you get precipitation, which is rain or snow, falling to the Earth's surface. So once it hits the Earth's surface, there's a couple things that can happen here. And that's one of the questions I asked you. Which two processes can occur in a terrestrial ecosystem once water reaches the land? So the first thing that can occur is, and I put this here, it percolates or sinks under the ground to become groundwater. So picture it, rain is coming down, here's soil. You've all seen that as the rainwater hits the soil, it sinks into the soil absorbs it. Well, that's one thing that can happen when precipitation occurs. The other thing is that water can hit plants, right? Plants need water, it's part of supplying the necessary inputs for photosynthesis. But let's say water hits the leaves. It can actually evaporate from that surface. Okay. Now, water can also form runoff. So really, I should have put which 3 processes can occur. So runoff means that water runs into like a lake or a river, right? It stays on the surface of the earth. I'm going to write this down for you here. I think I have enough room down here. So I wrote processes that can occur after precipitation hits the surface. So I'm going to write 1 here. Okay, so water can sink through the soil to form groundwater. Water can sit on leaves and plants or any surface really and evaporate, turn back into water vapor and go into the atmosphere. And I'm going to add a 3rd one here. You can't see that. Hold on here. All right, PowerPoint is not cooperating with me today. Okay, so the last one I wrote is that water can form runoff, which means it stays on the surface of the earth, usually in the form of like rivers or goes into lakes, something like that. Now, remember, if you want more information than what I'm providing in this lecture recording, you can go to the reading that I gave you. Okay. Now, surface runoff, like I've been telling you, occurs when water runs along the surface of the earth. So there's different conditions that can lead to runoff. So if the soil is saturated with water, it already has all the water that it can hold. When you get rain or snow, it will stay on the surface and will not sink into the soil because there's no more room. If you have a heavy rainfall, you can get runoff because the rain is coming down faster than the soil can absorb it. Finally, if the surface cannot absorb water, like in urban areas with asphalt. Also, what's interesting about the desert where we live here is our soil has a lot of clay in it in a lot of areas, and that does not absorb water very quickly. So it tends to stay on the surface as well. Now, water that is in the soil, right, our groundwater, is absorbed by the roots of plants. Now, here's another term that you need to know. What is transpiration? So basically, water is taken in by the roots, travels up the stem into the leaves, and there are tiny openings in the leaves of plants called stomata. And the water can leave the plant in the form of water vapor. So let me write a definition for transpiration. Oops. Okay, so there's a definition of transpiration. So water enters the roots, goes up through the stem into the leaves of the plant, at which point it can exit the leaf as water vapor. Okay, before I go on to the carbon cycle, I want to do a quick review of your learning objectives. So define the following terms. Groundwater, that is the water that is under the Earth's surface. It's stored between like soil particles. Evaporation, that is when liquid water enters the atmosphere as a gas or water vapor. Precipitation, water is falling to the Earth's surface as rain or snow. And transpiration, water enters a plant through the root, goes up the stem to the leaves, and it can exit the plant as water vapor. Now, all of these processes work together to cycle water through the ecosystem. So number two, the processes that can occur in a terrestrial ecosystem. Remember, terrestrial means like on land. Okay, so once precipitation hits the Earth's surface in a terrestrial area, it can cause surface runoff, right? It can evaporate from objects like plants, or it can sink into the soil. Now, finally, the relationship between these terms. So here on this slide is a picture I really like to show you that. So water is going to cycle from the surface of the Earth to the atmosphere and back down. So you have evaporation, takes water and puts it into the atmosphere. You get condensation where clouds form. Precipitation brings the water back to the Earth's surface. Infiltration, that's just referring to water going into the soil. Now it can be taken up by plants, and transpiration will put it back into the atmosphere. Okay, so I'm going to stop my recording here, and then my second recording will have the carbon cycle and the nitrogen cycle. And that's so that you can split up the amount of time you spend listening to the lecture recordings. So in this recording, I had the introduction and the water cycle.